So when we talk about our organic chemistry, what am I talking about? Now, there are certain compounds that occur naturally within nature that are composed of carbon, hydrogen, oxygen, nitrogen, right? These
Yes.
type of compounds are known as organic compounds. So when we talk about organic compounds, there is a very specific term, okay? That specific term is hydrocarbons. This is what we're starting with, okay? We're starting with the topic of hydrocarbons. Now, when we talk about hydrocarbons, what are hydrocarbons? Hydrocarbons are those compounds that have only hydrogen and carbon. That's it.
Mm-hmm.
Those compounds that have only hydrogen and those compounds that have only carbon, those compounds are known as hydrocarbons. Now, hydrocarbons are a type of organic compounds, okay? They're a type of organic compounds. But uh, when we talk about it, so if they ask you in the exam, what are organic compounds? So organic compounds can have hydrogen, they can have carbon, they can have nitrogen, they can have sulfur. Hydrocarbons are a classification. They're a category inside organic compounds. And they have only hydrogen and they have only carbon. So
Okay.
first of all, let's do the definition. What are organic compounds? Organic compounds are those compounds which have one or more carbon atoms covalently bonded to atoms of other elements. I'll in fact write it down for you, right? Those
Okay.
compounds that have one or more carbon atoms covalently bonded to other elements. And the most common elements that we find in organic chemistry are hydrogen, oxygen, nitrogen. These are the ones that are most commonly composed. Now, inside organic chemistry, then we have got other types of compounds. We have, for example, we are starting with today hydrocarbons. We have alcohols. Alcohols are a type of organic compounds. We will study about carboxylic acid. Those are a type of organic compounds. So let's start with hydrocarbons. When we talk about hydrocarbons, I told you that hydrocarbons contain only carbon and hydrogen. That's it. Hydrocarbons can be further divided. So I can take a hydrocarbon and I will generally deal with two types of hydrocarbon in my syllabus. You will study about alkanes and you will study about alkenes.
Okay.
Let's start by talking about alkanes. The primary difference between alkanes and alkenes is that alkanes have only a single covalent bond. That's it. The carbon atoms will have only a single covalent bond. Alkenes can have double covalent bond. How how does it look like? Let's start with alkenes. So alkenes start like this. I have one carbon atom. This carbon atom is attached to, so carbon is in group 4, right? Which means
Yes.
it can make maximum of 4 covalent bonds. So I have one carbon atom. This one carbon atom can attach to 4 hydrogen, right? If I make a dot and cross diagram, this is what it will look like. This is an alkane. Why is it an alkane? Because it has only a single covalent bond, no double covalent bonds between carbon atoms, right? Between the carbon
Yes.
atom, there is no double covalent bond, and right?
Mm-hmm.
How am I going to name it? What am I going to give the name? So when we are naming organic compounds, we have a suffix, like you have in English. We have a suffix and we have a prefix. I wrote it the other way around. We have a prefix and we have a suffix.
Okay.
The suffix is the compound, the type of compound. So for alkanes, the suffix is fixed. It is A-N-E. It's fixed, right? The suffix
And
is
for
A-N-E.
alkene is ENE?
A-N-E, exactly.
Okay.
And what is the prefix? The prefix is the number of carbons. So when we have one carbon, we use meth. And this is not just for hydrocarbon. In the entire organic chemistry, if you see meth, for example, in this case, it becomes methane, right? If
Means
I
it
am
has
using
single
an,
covalent bond.
yes, if I'm making a alcohol with one carbon, methanol, right? The suffix will change, but wherever you see meth, what does that mean? One carbon atom. Similarly, what happens when I add two carbon atoms? So I will have one single bond between two carbons, and then I will draw the hydrogen. 1, 2, 3. 1, 2, 3. So I have to make sure when you're drawing the structure, make sure that carbon has all four bonds. So this carbon, I have drawn four bonds. One over here with carbon, then 2, 3, 4. This carbon also has four bonds. One over here, and then 2, 3, 4, right? This has two carbons. How will I name it? The suffix will be the same. In. What do we call two carbons? What's the word we use for two carbons? Eth. So, ethane, right? Similarly, if I have an alcohol that is two carbons inside of it, what will I call it? Ethanol. If I have an alkene with two carbons in it, what will I call it? Ethene. So, ethene is for two carbons. Then we can have three carbons. 1, 2, 3. And then you're going to add the hydrogens. So each carbon will make 4 bonds. So I will count 1, 2, 3, 4. For the second carbon, I will only draw 2 hydrogen. Why? Because it already has a bond over here and a bond over here. So it already has 2 bonds. So I make 3, 4, and that's it. I'm done. This is the structure of 3 carbon alkane. What is the suffix? The suffix will be ane, A-N-E.
Why will
What
it
is
be
going to
ane?
be the, sorry?
Why will it be ane? Like alkane.
Yeah, the suffix is fixed. The suffix is fixed, A-N-E, okay? So suffix is
Okay.
fixed, suffix will be A-N-E. Whenever it's an alkene, whenever. If it is an alkene, it has one single covalent bond between the carbon atoms, you will write down A, automatically A. What you have to figure out is what is the prefix. The prefix will change. The suffix will remain the same. Okay? So
Okay.
when we have 3 carbon atoms, we call it propane. Propane. Propane is 3 carbon atoms. So when I say propane, you will instantly say, okay, ane means it's an alkane, only one covalent bond between the carbon atoms. Prop means there are 3 carbon atoms, and you will be able to draw this picture. Right? Similarly,
Yes.
yeah,
There
go
will
on,
be there will be 2 covalent bonds if there are double bonds between carbons.
yes, if there is a double bond between the carbon, then you will have then you will have a covalent bond between the carbon.
Okay. So then it will
But
be
then
ene.
yes, then it will be E. Then it will be E. So if there's a double bond between the carbon, then it's going to be E. If there's a single bond
Okay.
between the carbon, then it's going to be E.
Okay.
Right?
Yes.
Similarly, let's take 4 carbons. 1, 2, 3, 4. And then I will draw the hydrogen. So I will draw one hydrogen over here.
Hexane.
No, this is not called hexane.
Okay.
1 second, I'll tell you. This is what the structure will look like. I have to make sure, first draw the carbon atoms and then add the hydrogen to it, right? So you have to make sure that each carbon has 4 bonds. So this is carbon, 1, 2, 3. This is the 4th bond. Then the second carbon, 1, 2, 3, 4. So each carbon should have 4 bonds, right? This is
Yes.
going to be known as butane. 4 carbons. Wherever we have 4 carbons, we use the word but. So when you say to me, Miss, I have butane, what does that tell me? I'll say, okay. Ane means you have an alkane, and
Is a single bond
but means,
between carbons.
yes, it has 4 carbons. Exactly. Similarly, what if we have 5 carbons? If it's 5 carbons, we call it pentane. If we have 6 carbons, we call it sane,
Okay.
right? So, this is basically how it is going to be happening. Then I think 7 carbons is heptane. Heptane.
Then oxane.
Then octane.
Octane.
Yeah,
Octane.
yeah.
Octane.
But you don't generally get to that. You don't generally deal with in your past paper questions. Hexane is the maximum it goes to. They don't ask you any further than that. Now, let's take a look. I told you that uh, we have methane, right? Methane.
Yes.
We have methane. So methane means that we have 1 carbon atom, right? And it needs to have 4 bonds. So how many bonds will it have? It will have
4.
4 hydrogen because it's meth, meaning that there is only 1 carbon, there is no other carbon. So we will have 1 carbon and it needs to have 4 bonds, it will have 4 hydrogen. If I say, Arham, can you tell me what is the molecular formula? So what will you say is the molecular formula? You will say, okay, miss, there is 1 carbon and there's 4 hydrogen. So the
CH4.
molecular formula is exactly. Then what about ethane? So ethane, you will automatically say, okay, eth means 2
CH5.
carbon. None,
Maybe.
not CH5. Not CH5. That's why
Okay.
we're drawing the structure. We have ethane, right? So what are we going to do? Eth means 2 carbon. So you write down 2 carbons. Okay. After making the 2 carbons, what are you going to do? You are going to draw the hydrogen.
Hydrogens. 3 hydrogens on each side, right?
3 hydrogen on each side. Correct. 1,
Okay.
2, 3. And then 3 hydrogen here. What will be my molecular formula? C2H6.
C2H6.
Exactly. Then what if I move on even further? What if I go to propane? So you will say, okay, Miss, propane is 3 carbons. 1, 2, 3. And then I will add the hydrogen. 1, 2, 3.
C3H8. No, 10,
1,
I
2,
think.
1. C3H8.
Okay.
Similarly, let's go to butane. 1, 2, 3, 4. 1, 2, 3. And then 1, 2, 1, 2, 1, 2, 3. C4H
12. I'm 10.
H, right?
Yes.
Similar. So you will see that all of them seem to be following a trend, right? That
Yes.
trend, we call it general formula.
The carbon
General
increases by 1 and hydrogen increases by 2.
by Carbon increases by what?
1.
Nah. 2n plus 2. What do I mean by that? Let's say I say, Anam, tell me the formula for ethane. You will say, okay, ethane is an alkene. The formula for alkene is CnH2n plus 2. Okay? How
Yeah.
many carbons are present in ethene? 2 carbons. So N is equal to 2.
Okay.
C2H2 multiplied by 2 plus 2. Right?
Yes.
C2H, 2 2s are 4. 4 plus 2 is 6. This is what we got
Okay.
as
So the n like the nth term depends on the number of carbons.
number of carbon. Exactly. So now if I come up to you and I say, Alam, can you tell me what will be the molecular formula of pentane?
Okay. 5. It will no, it will be like 5. N will be 5. So
Yes.
C5 H12.
C5H12. Correct. So this formula is known as general formula, okay? And this general formula is, one second, let me tell you. So this is what the structure is going to look like for pentane. And this will be the molecular formula. So this is the general formula for alkanes. It's fixed, right? For alkanes, the general formula is fixed. It is CnH2n plus 2. Now, when we talk about the general formula is specific for something that we call homologous series. What is homologous series? Homologous series is a group of compounds that have the same general formula. So, for example, alkanes are one homologous series. Why? Because all alkanes follow the same general formula.
Okay.
Alkenes are another type of homologous series. They follow another general formula. So when I will teach you alkenes, you will see they also form a specific formula. Alcohols also follow a specific formula. So any group of compounds that has the same general formula, they have the same general formula, they have similar chemical reactions, and they have they follow a specific trend in physical
Properties.
properties. So any group of compounds that has all three things, we call them a homologous series. So alkanes are a homologous series. They have the same general formula. Their chemical reactions are all similar to each other, and I will teach you their chemical reactions.
Like a
Chemical
group.
reactions.
Like a group.
Yes, like a group. So like for example, if I ask you methane, combustion reaction of methane, the reaction is the same as ethane, propane, butane. They will do combustion in the same way. The products will be the same, carbon dioxide and water. It won't change, right? The reactions remain the same. The reactions are similar to each other, right? And when you look at the physical property, you will be able to see a proper trend. What trend will you see? Let me go ahead and tell you. The trend you will see is you're going to see a trend like this. First thing, the physical state, right? From methane till butane. So from carbon number 1 till carbon number 4, they're all gases. Okay? Then after carbon number 4, they start turning into liquid. And eventually, as the carbon number keeps on increasing, at some point, they will start turning into solid.
Solid.
So that's a
Okay.
trend. We can see a trend that as the number of carbon is increasing, the state is changing from gas to liquid to solid.
Okay.
Similarly, the melting point decreases. So it's following a trend. I can see that the melting point is decreasing. I can see that particular trend that is happening, right? I can see that trend happening. I can see the melting point is going down. I can see that the boiling point is also following a specific trend. It's going from negative towards positive.
Positive.
So boiling point is increasing. Basically, melting point is also increasing because this is negative, right? So it's becoming less negative, which means
Mm-hmm.
it's getting higher. So melting point is increasing. Boiling point is increasing, right? What does that tell us? That it's following a specific trend. The physical properties are following a very specific trend. Both the melting point and the boiling point are increasing, right? It's following a very specific trend. So this is because alkanes are a homologous series. Their physical trends are going to follow a specific pattern. So in our case, melting point and boiling point will increase, right? The state is going to turn from gas to liquid to eventually solid. If I remember correctly, I think if you have more than 16 carbons, then it becomes a solid. So from 5 carbons to 16 carbons, it's liquid. And then from 16 carbons more, it becomes solid.
Why is there so much difference? Because here we after fourth
Mhm.
carbon it becomes a liquid. So why after
Mhm.
16th carbon it becomes a solid?
Because when you talk about liquid, so for anything to turn from gas to liquid, it's not that hard in terms of intermolecular forces. Because intermolecular forces, even though liquid has more intermolecular forces compared to gas, more forces of attraction compared to gas, but they're still weak. But a solid has really, really, really strong forces of attraction between the atoms, right? Between the molecules. So
Mm-hmm.
for that transition to take place, for the organic compound, for our alkane to develop that strong attraction, we need a lot of carbon atoms for it. So when there are a lot of carbon atoms for it, then the molecule forces of attraction get strong enough for it to turn from liquid to solid. That's why. So from
Okay.
gas to liquid, it's not that much of a difference because gases do have, liquids do have forces of attraction, but they're not that much, right? They still have weak forces of attraction. In a solid, it has to be really strong. So you need that force of attraction. So for that, you need a good number of carbon atoms, right? Because
Okay.
when we talk about your hydrocarbons, okay, this is a little bit out of your syllabus. When you do your A levels, you will study this in more detail, but just a slight concept, just for your understanding. When we talk about forces of attraction, so different types of compounds, we have different type of forces. Okay, we have some forces that are weak forces. Okay, we call them uh, von der Waals forces. That's their name. They're really weak forces. Then there's some molecules that have stronger forces of attraction, like hydrogen bond. Okay, so
Mm-hmm.
the m- molecule, the structure of the molecule is what decides what type of attraction it has. So in alkanes, generally, the forces of attraction are really weak. The weak forces of attraction are present. We don't have the stronger forces of attraction. So for it to transition from liquid all the way to solid and have that, compact structure, we need to have a good number of carbons inside the molecule. That's
Okay.
why. When we talk about our topic of, so we talked about in alkanes, we have gone over the structure of alkanes. We have gone over how to name our alkanes. We have talked about
Mm-hmm.
their
The formula.
physical properties, right? Yeah, we talked about their physical properties. So I told you they also have similar chemical reactions. Okay, now the chemical reactions of alkenes that you have to study are only two, by the way. Alkanes are very easy in the sense that there are only two types of reactions. There's a reason for that. Alkanes are non-reactive. Alkanes are generally very non-reactive. The reason for that is single covalent bond. A single covalent bond is stronger than a double covalent bond. Remember that. And you will study why and how, all of that when you do A-levels, you'll study a whole chapter on that. So single covalent bond is stronger than a double covalent bond. Remember that. In a double covalent bond, one bond can break. A single covalent bond is very strong. Because alkanes only have a single covalent bond, they're very non-reactive. Okay? And they also do
Okay.
not have any other elements. They don't have any oxygen. They don't have any OH group. Alcohols have OH group. Then we have acids, carboxylic acids. They are proton donors. Alkanes have nothing. Alkanes just have carbon and hydrogen and only single bonds. So alkanes are generally very non-reactive. Two types of reactions you have to study in alkanes. One is a reaction you have been studying probably from grade 8, combustion reaction. Okay. One thing about alkanes, remember this, alkanes are naturally occurring, meaning that we will find them in nature. And where am I going to find them in nature? Crude oil. Crude oil is a fossil fuel, right? Crude oil is
Yes.
actually composed of this. It's composed of alkanes. It is composed of alkanes. Alkanes can be found in nature. They're found in crude oil, specifically in crude oil. Okay. Now,
Okay.
so what is one of the major reactions for alkanes? Combustion, because alkanes are found in oil. And what do I use oil for? I use oil as a fuel. I burn oil to produce heat energy. So the main reaction that that takes place with alkanes is combustion reaction. What is combustion reaction? When our alkane reacts with oxygen to give us carbon dioxide and water. This is the combustion reaction, same as what you've been studying so far. And in the process, it releases huge amounts of energy.
Heat. So
If,
exothermic.
yes, it's an exothermic process, correct. If the process is, if you have enough oxygen, you will have complete combustion. If you do not have enough oxygen, you will have incomplete combustion. In incomplete combustion, what do we get? Carbon monoxide plus water. Carbon monoxide is a toxic gas. How is it a toxic gas? It binds to hemoglobin.
Hemoglobin.
It binds permanently. It binds permanently to hemoglobin. So oxygen cannot be transported inside the body, right? The
Yes.
hemoglobin will bind to carbon monoxide. So how is oxygen going to be transported, right? Then we
Okay.
have carbon dioxide. Carbon dioxide is a greenhouse gas. And I will teach you what the greenhouse effect is. I'll teach you the greenhouse effect. It is a greenhouse gas, meaning that it is contributing to
Global warming.
climate change and global warming. Exactly. Now, there's another reaction that takes place with alkanes, and that is reaction with halogens. Halogens meaning chlorine, fluorine, bromine,
Group 7.
iodine. Yeah, group 7. Now, there is a condition to this. Alkanes will only react with halogens in one particular condition, and that condition is UV light, ultraviolet light from the sun, or UV light, wherever it's coming from, but mostly from the sun. UV light is needed. Without UV light, alkanes will not react with halogens. Why? The reason for that is because I told you alkanes are very non-reactive because they have a very strong single bond. For that bond to break, we need UV light. Now, how does the reaction take place? Let's go ahead and study that. Step number 1. Now, this reaction happens in our atmosphere. Okay? This reaction is happening in the atmosphere, not inside a laboratory. I can do it inside a laboratory, but then I'll need a special setup. This is happening inside the atmosphere. It happens naturally as well. Okay?
Mm-hmm.
What happens? It happens like this. I have chlorine gas. Let's say we are taking halogens, right? Let's take chlorine. I have chlorine gas in my atmosphere. Now, chlorine is a diatomic molecule and it is made up of a single covalent bond, right? One shared pair of electrons. Now, what will happen that the sunlight, the UV light is going to break the bond between the two chlorine, this covalent bond between the two chlorine atoms. So the chlorine molecule Cl2 will break down to give you two chlorine, okay, two chlorine. But these two chlorine are not atoms. They are a special species, a chemical species we call free radicals. Can you see that they both, so over here when they had the covalent bond, they were sharing a pair of electrons, right?
Yes,
And
yes.
both of them had 8 electrons. Now what has happened is that the bond has broken and from the shared pair of electrons, one electron has gone to one chlorine and the other electron has gone to the other chlorine. So now they do not have a complete outer shell. They have one electron is with one chlorine and the other electron is with the other chlorine. So they have formed a new kind of species that you and I have not studied about before, and that is free radicals. How do we write them down? This is how we write it down. We write down Cl and then we put a dot in the top. So wherever we put a dot, that means that it's a free radical. Now, the thing about free radicals is that they are super, super, super duper reactive, like extremely reactive, right? Why? Because they don't have a complete outer shell, right? It does not have a complete outer shell. So they're really, really, really reactive, right? They're
Mm-hmm.
extremely reactive. So what is going to happen? I have my step number one. I have chlorine. That chlorine broke down to give me chlorine free
Free
radicals because of
radicals.
sunlight. Now, I have my methane. Let's take methane. Let's go easy. It has just one carbon. Easy for us to study. This chlorine free radical is so reactive that it is able to break the bond between carbon and hydrogen. I told you that single covalent bonds are really hard to break. Really, really hard to break, right? That's what I told you. But this free radical is so reactive that it will come to methane and what will it do? It will attack the bond between carbon and hydrogen. It will break the bond between carbon and hydrogen. And then what will happen? What will happen is this. This hydrogen will combine with the chlorine and you will get HCl gas, which is hydrogen chloride
You're
gas.
right.
Now, there's a small problem. Can you see what the small problem that is happening is? The small problem that is happening is that now we have this CH3. I told you a carbon makes 4 bonds. Over here, carbon is making just 3 bonds, which means
Mm-hmm.
now this organic compound has turned into a free radical. This free radical is known as a methyl. Methyl free radical, right? Methyl because it has one carbon in it. So what will happen? I will end up getting this CH3 free radical, right? So my chlorine free radical is attacking my methane. That is the normal gas inside in the atmosphere. And
Yeah.
it is reacting with the free radical to give me hydrogen chloride gas and a methyl free radical.
But
Yep.
wasn't there two chlorine atoms? Like it
Yes,
says it
there
was
are two.
Cl2.
Yes, there are two chlorine atoms. The other chlorine atom can attack another methane. The other chlorine atom can attack another molecule of methane.
Okay.
That's fine. You're right. There are two chlorine atoms, and it can attack another molecule of. It can attack another molecule of methane. Or okay. Now what happens? So this is basically what is happening over here is that okay. I'll show you. After that, now I have the methyl free radical. What happens to the methyl free radical? What will the methyl free radical do? Right? It is also really reactive. It also wants to react with something, right? So
Mm-hmm.
what is going to end up happening? That this methyl free radical will react again with chlorine gas. And this methyl free radical will break the covalent bond. This methyl free radical will break the covalent bond between chlorine and chlorine, and it will take this chlorine and attach it to itself. So we will end up with CH3Cl. CH3Cl. So it wants to have 4 bonds. So it's like, listen, I want 4 bonds. I don't care how I get it. I'm going to attack another chlorine gas. I will break another chlorine molecule, and I will take the chlorine atom from there, and I will become CH3Cl. But there is another problem with this. The problem is that now we have another chlorine free radical, right? So this is a chain reaction basically. It keeps on happening. So chlorine gas will give us chlorine radical. The chlorine radical will attack methane, and it will say, listen, I'm taking the hydrogen. I want to have a complete outer shell. It will make a bond with hydrogen. But now methyl has turned into a free radical. Now methyl wants to have another bond. It wants to make another bond. So it will go to another molecule of chlorine, and it will say, listen, I want to have a complete bond. I want to have all 4 bonds. So I will take one chlorine. Now we have another chlorine free radical. Now this free radical of chlorine will go back to methane. It will go back to step number 2. And again, step number 2 will happen. Then again, step number 3 will happen. So you see that this is a chain reaction, right? One after the other, after the other, after the other. And eventually, what will happen? A few things can happen. One thing that can happen is that all of the methane is used up. The methane or the chlorine is finished. If there is no more methane, if there is no more chlorine, the reaction will stop. The other thing that can happen is that two free radicals can join with each other, right? Meaning that two chlorine free radicals can join with each other and make chlorine gas. Or two methyl free radical can join with each other and make an organic compound. But that's not, you don't have to know it in that much detail. So, but this is a chain reaction, one after the other after the other. And this compound that I'm getting at the end, so the group name for the compound, the group name for the homologous series would be halogenoalkane. Halogenoalkane means that we have the alkane and it is attached to the halogen. How do we name it? We name it the same way I taught you, but we add the halogen, right?
Okay.
Meaning
Yeah.
that what would we name this? I told you that this is 1 carbon, which means is meth. We have one single covalent bond, so we will write down ene, and then I will write on the name of the halogen. So I have chlorine. So I will write down chloro. So this compound is known as chloromethane. Similarly, if I had C2H5Cl and I asked you to name it, you would say, okay, miss, 2 carbons is eth, and this is an alkane.
In
So in, yeah, and then I put a chloro in the front. So chloroethane, right? So this is the name of the group is halogenoalkane. So halogenoalkane, it could be bromomethane, iodomethane, fluoromethane, right? Any
mm-hmm.
halogen. And then you have the
Okay.
alkane at the front. So this chain reaction will keep on happening, and this is how you're going to get the halogenoalkane. So, and this is the overall equation. If you just want to write, this is the whole process, and this is the overall equation, that methane will react with chlorine to give us chloromethane and hydrogen fluoride gas. What is this reaction called? This reaction is known as a substitution reaction.
It's a new type of reaction. It wasn't there
Yes,
before.
it was not there before. And when we do alkenes, you will study about an even newer type of reaction, right?
Okay.
This is a substitution reaction. Why substitution reaction? Because what is happening? I started with CH4. It had 4 hydrogen. I had to remove 1 hydrogen to place the chlorine. I had to substitute, right? I didn't add to it. I didn't do anything else. I had to substitute. I had to remove a hydrogen, and in place of it, I had to put chlorine. I had to remove a hydrogen and put chlorine in its place. So this is a substitution reaction. So if in the exam they say what type of reaction happens with alkanes, alkanes always have substitution reaction. What type of reaction happens with alkenes? It is always substitution reaction. And when does it happen? It happens only in the presence of UV light. That's it. In the presence of UV light, a substitution reaction is going to take place, and instead of hydrogen, a chlorine is going to be substituted. A chlorine is going to be placed in place of the hydrogen atom. So substitution reaction, and these are the only 2 reactions we have in alkanes. We have combustion reaction, where we are taking an alkane, burning it in oxygen to produce carbon dioxide, water, and our energy, right?
Mm-hmm.
And along with that, this is the second reaction where we reacted with a halogen. But for this, we need the presence of ultraviolet light, and this is the chain reaction that is present for it, right? And all of the
Yes.
chain reactions taking place because of free radicals, right? The free radicals are strong enough to break the covalent bond. If there were no free radicals, we would not have any covalent bond, right?
Mm-hmm.
Okay. And basically, this is how we get the concept of chlorofluorocarbons. Now, you might not have heard about them because we don't use them anymore. But a few years ago, we used to use chlorofluorocarbons. So they were organic compounds. But they had fluorine and fluorine. So they were basically halogenoalkane. They were this. They were halogenoalkane,
But there were
but they had,
two
yeah,
halogens, right?
yeah, yeah, yes, chlorine and fluorine both were present. So we call them chlorofluorocarbon. Now, chlorofluorocarbon at one point were really popular. The reason they were really popular is because they were, used commonly in your aerosols, your sprays, deodorants. They used to be made of chlorofluorocarbons. The cooling system, the coolant liquid in your refrigerators, that included chlorofluorocarbons, because they said they're inert. Because the people were like, the scientists were like, oh, it's inert, it's non-reactive, it's an alkane, it's a halogenoalkane. Alkanes are non-reactive. That's literally what I just told you. But eventually, what started happening was that when this chlorofluorocarbon would go in the atmosphere, it was exposed to the UV light. And that UV light would make it into a free radical. And that free radical started to react with the ozone layer. And that is why you must have, you've been studying it for years. Ozone layer is getting damaged. Ozone layer is getting depleted. This is one of the reasons. Okay. So now
Okay.
we don't use them anymore. Now the scientists have figured out that they are damaging the ozone layer. So they're not used that anymore, but they were quite common at one point. Your aerosols, anything that was aerosolized, your deodorants, your sprays, refrigerators, anything at all that needed an inert compound, they used chlorofluorocarbon, and they were very happy about it. They said that it does not react with anything. It's inert. It doesn't react. It's not harmful. Of course, then later on they discovered that the UV lights were causing it to turn into a free radical. And because free radical is extremely, extremely, extremely reactive, it would react with the ozone layer, and that's how the one of the reasons the ozone layer was getting damaged. And of course, they've discovered it after uh, quite a number of years. So
Okay.
that is one sort of environmental problem with alkanes. Another environmental problem with alkanes is, of course, the combustion reaction in which we are producing carbon dioxide gas, that is a greenhouse gas, and then methane. Methane is a natural gas. It occurs naturally and it's mainly produced by cattle, cows. They produce it when they are breaking down their food. When they're digesting food, they produce huge quantities of methane. Rice, the plant rice, also produces a huge quantity of methane. So methane and carbon dioxide are both greenhouse gases. Okay, so basically what happens is this, that the light that is coming from the sun, it comes in the form of UV light, ultraviolet radiation. Okay. Now, what happens is this, to understand this, you need a little bit of the concept of electromagnetic spectrum from waves. I don't know if you've, from physics. If I don't know if you've studied it or not, but basically what happens is that we have ultraviolet ray. That's the one that comes up from the sun. Then the surface of the earth gets hot. And when the surface of the earth gets hot, it produces infrared radiation. Now, the infrared radiation is not able to escape the greenhouse gases and it gets sent back to the earth. So ultraviolet radiation has a different wavelength. If you've done physics, you might know this. Ultraviolet radiation has a different wavelength. So it can pass through the greenhouse gases. But when the surface of the earth gets hot, it produces infrared radiation, and that cannot escape the greenhouse gases. So it gets sent back, so it gets trapped out, and that is causing global warming. And this is known as greenhouse effect. Clear? Any confusion?
No.
Okay, Aram, we'll go ahead and stop it over here for today.